Hi, I'm Tarini Singh, and I'd like to answer a question that's been plaguing me since the beginning of time, or rather, 8th grade science. Can you actually touch something? For this, we'll have to go down to the atomic level and touch up on a few things.
As you know, all matter is made of atoms. Atoms are made up of a nucleus, of protons and neutrons, and that nucleus is surrounded by electrons. Electrons are negatively charged and thus repel each other. Why? Because as they come closer together, they exchange a photon which pushes the both of them off.
It's sort of like how if someone were to throw a heavy ball at an ice skater, they'd be pushed back, and the same thing would happen if that ice skater were to throw the same heavy ball at someone else. So since electrons repel each other, they never actually come in contact with each other, which means that you are technically hovering by a small distance from the ground or the seat in which you're standing or sitting on. Insane, right? There's also something called the Pauli exclusion principle, which basically states that two objects with mass can't occupy the same space at the same time, so they're not touching. Here, I have the scrumptious banana, whose taste no other food item can touch. When I touch this banana, my atoms are not actually coming into contact with the banana's atoms. That's bananas, you might say. Then how are you perceiving that smooth surface? Well, our perception of touch is really just us perceiving that repulsion of electrons. Our brain perceives the electromagnetic force as a sensation. This also means that different things with different atomic structures are perceived differently, giving us texture. If two atoms were able to touch, we'd get a pretty nuclear result.
But then if nothing is touching anything else, then why does friction exist? After all, if they're hovering above each other, shouldn't they glide along smoothly? Well, this only occurs if the surfaces are extremely smooth. However, most surfaces have small imperfections that don't allow them to move past each other as easily. This friction is caused by chemical bonds or intermolecular forces and similar factors, all of which don't require actual physical touch.
Say that even by not physically coming in contact with each other, atoms don't lose their touch for forming bonds.
This also means that when you cut through something, you're actually just pushing the other atoms out of the way without ever touching them.
Is touch? Is it when two objects become so close together that there's no space left in between them? Because then yeah, you can't touch. But electrons work as both particles and waves, or rather a particle is an excited state in a wave-like field.
So while electron particles can't touch, electron waves can overlap. This is demonstrated by this ring of iron atoms on the surface of copper. As you can see, the waves overlap. So does wave overlapping count as touching?
Perhaps after all this time, the true answer to this question lies in the meaning of touch. According to some, touch may be possible, while to others it isn't. After all, we all have our own personal touches to that definition, as our individuality allows for it. That's quite touching.
You can't touch this. You can't touch this.